Hello and welcome to another session in mathematics. In this session we'll be looking at variations. But before that, let us look at the previous lesson. Welcome back. In this lesson we'll be looking at the types of variation, which include direct and indirect variation, and then we'll look at application of variation. Okay. The word variation is a system of explaining the relationship that exists between two quantities. The relationship that exists between what? Two quantities. That is what variation is. The relationship that exists between what? Two quantities in terms of price, or how the two quantities affect what? Each other. Okay. Let's take for instance, let's say matches. Let's assume that a box of matches is sold at $2, and we want to purchase about 20 boxes of matches. So it would then be 20 times what? $2, and that will give us what? $40. Okay. Now let's assume that someone does not have up to $40, so it will be impossible for you to buy what? Up to the 20 boxes of matches which is required. So we say that the price of matches affects what? The number of matches to be purchased. Now at this point, these two variables or two quantities affect what? Each other. Okay, so let's quickly look at the types of variation. We have the direct variation. In the direct variation, if someone wishes to buy, like I said earlier, a box of matches which is sold at $2, now it's equal to what? 1 times $2, right? And that will give us what? $2. Now if someone else decides to buy 2 boxes of matches, then he have to spend what? 2 times what? 2 to give us what? 4. If someone else decides to buy 4 boxes, then he will have to spend what? 2 times what? 4, which will give us what? $8. Do we understand? So we say that the price and the number to be purchased is directly what? Proportional. They are directly what? Proportional. Okay, so let's take one example on this. Assuming we have a packet of sugar to be equal to, let's say, $X. X can be any price, it can be any number at all. The question is, what will be the cost of 20 packets? Now this is very, very simple if you understood what I explained earlier. Now a packet of sugar is sold as what? $X. X can be 10, it can be 20, it can be 100, or whatever. So if the price of just a packet is $X, how much will 20 packets cost? Very simple. The price of 1 is equal to what? X. So therefore the price of 20 will then be equal to what? X times what? 20. Is that correct? And then we have what? $20X. As simple as that. I hope we're following. Okay, let's take one more example. We have number 2 here on the screen. If m varies directly as L and m is equal to 6, when L is equal to 2, find A, the relationship between m and n, B, the value of L when m is equal to 15. Okay, Okay, now they said M varies directly as what? L. This is pronounced as what? Varies. Okay, M varies directly as L. If M varies directly as M, then it means that M is equal to K L. The word, this letter K is what? A constant. K is a constant. K is a constant. M varies directly as what? L. So M is equal to what? KL. This is the general acceptable formula. Okay, now if this is the relationship that exists between M and K, so what is now the value of M and what is the value of L? Let us now use it and find the value of what? K. Okay, our M is given to be 6 from the question. You see it? M is 6, and then L is what? Is 2. So we have K times 2. Is that correct? And then we have 6 to be equal to 2K. Is that correct? 6 is equal to what? 2K. Then we proceed. If 6 is equal to 2K, what is now the value of K? K then will be equal to 6 over 2, which is equal to what? 3. That's the value of what? K. Okay, now since we've found the value of K, the next thing we will do is now to begin to solve the questions on the problems we have here on the screen. Number 1 said we should find the relationship that exists between what? M and N. This is the relationship, like I said earlier. That's the relationship. And then number 2, they said we should find the value of L when M is equal to 15. Remember our formula, M is equal to KL, and then they gave us M here to be what? 15. Of course, K is gotten to be what? 3 times what? L, because L is not given. So 15 is equal to 3L, making L the subject of formula. L is equal to 15 over 3, and then L is equal to what? 5. Have you seen how simple it is? As simple as this. So let's look at inverse variation, the second type of variation. Inverse variation. Okay, I want to explain that with the diagrams on the screen. The first diagram has 5 equal sectors, 1 2 3 4 5, with each angle as what? 72, and 72 times 5 will give us 360. And then when you look at the second angle has 12 sectors, 12 equal sectors. Okay, with its angle as what? 30. 30 times 12 will still give us 360. Now, what is the point we want to drive here? The point we want to create here is this: the greater the number of sectors, the greater the number of sectors, then the smaller the angle of each sector. Let me explain that. I said the greater the number of sectors, then the smaller the angle of what? Each sector. Now look at this. In illustration 1, we had what? 5 sectors, and 360 divided by 5 gave us 72 degrees. That's how we got this 72. But in the second diagram, the second figure, we increased the number of sectors to 12. So we now have 360 divided by 12, which will now give us what? 30 degrees. So as the sector is increasing, then the angle in each sector is reducing. Now that relationship is what we call what? Inverse variation. That relationship that as one is increasing, the other is reducing, that is what we call what? Inverse variation. Okay, let's take some examples on this inverse variation. Okay, we have a problem on the screen. It said if theta varies inversely is represented by what? 1 over n. If theta varies inversely and theta is equal to 72 when n is equal to 5, he said we should find theta when n is equal to 12, and then find n when theta is equal to 8. Okay, let us apply what we know and see how it goes. Number one, we are told that theta varies directly as what? 1 over n. Okay, and now our 1 here is a constant. Is that correct? So since 1 is a constant, we have to replace it with what? With k, which is the normal form of our constant. So therefore we have this to be equal to theta equals k over n. Do we understand? So now this is the relationship that exists between theta and what? And n. Okay, let us continue. Now they said we should find theta when n is equal to 12. But the first thing we need to find here is what? Is k. That's the first thing we need to find. We find the value of what? K. Now theta from the question is given to be 72. We write down 72, and then we have our k all over n. N is given to be 5 from the question. Is that correct? Yeah, let's move on. 72 times 5 is equal to k. Is that correct? Yeah. Now 72 times 5 will give us 360 to be equal to what? K. So our k is equal to 360. That's the value of what? Our k, which is constant. Okay, let's proceed. Now the first question said we should find theta when n is equal to 12. Find theta when n is equal to 12. Okay, so we have our original equation to be theta equal to k over n, and theta is not given. Our k is 360 and our n is what? Our n is 12. So 360 divided by 12, what would be the answer? Theta is equal to what? 30. Okay, then the b part of it said we should find n when theta equals 8. Okay, we still bring down our theta equals k over n. Okay, so theta is given to be 8. So here we have 8 equals 360 all over n. Is that correct? Yeah. So we have n times 8 to give us what? 8n equals 360. Then n will then be equal to 360 divided by 8. 360 divided by 8, what do we have? We have what? 45. Okay, as simple as that. Okay, to refresh our memory on what we've been doing so far, I want you to take the test on the screen. Welcome back. We've been able to treat the definition of variation. We've been able to cover the types of variation, which includes direct and inverse variation. We'll stop here for today. In our next class, we go over to the remaining 2 types of variation. Okay, do well to use the lesson note on the platform for better information on the topic we've discussed. Feel free to drop your question on the comment section. Till we meet again in our next class, stay safe and bye.